Okay, today is 16th session. I open the reference, the book, and then share the screen. Salam. Hi to the students. Okay. In the name of God, and good afternoon to all of you. I hope to be fine. About 2 or 3 sessions that we have started the studying of a Rashid book. It is related to a neural network, and in the following we will see about the deep learning and the Python coding. We want to learn about this topic. If you remember, I put it in this way and use 100 is okay. Yeah. If you remember, at first we stated that about the classification, and then step by step we have developed if one linear classification is okay and is sufficient and usable for our data, then how we find this linear classification. And then after that we said that okay, sometimes this linear classification is not good for us because of our data. If you remember, for example, we have XOR data, and then for those data, one linear classification was not enough proper. And then, for example, just a minute, I bring the here, for example, it is the data is related to XOR, and for example, for this logical XOR data, we need 2 lines for classification. And then after that, we said that okay, sometimes linear classification is not sufficient for our data. Then we need nonlinear classification, and one of them is a neural network, and the neural networks base is according to the human neural networks. Then we define the neuron and the concept of the some neurons. And we modeled the neuron, and then introduce activation function. For example, said in this area we have output, and in other area we don't have any outputs. These concepts come back to actions. The famous is a sigmoid function. The function is the mathematical equation is about the input-output hidden connection between neurons. The weightings is a connection in a way, and said that how the neural networks acts, and for why we consider errors, because we wanted to update the data and the weighting of these connections. We want to have the best, have optimum neural networks according to the we tried to present and we explain three-layer neural network. We after that we set that data, and we linear classification is usable for our data. We use error. Using the error, the calculated error, we could access the proper slope of the linear classification. Then, according to this concept, we want to find the best weightings. Okay, and then we said that okay, we have two strategy. One of them is that we divided the error in equal ratio, and then using these equal errors we can update the weightings. Another strategy was that we said that okay, for example, in this diagram, the effect of the W11 is more than the W21 on the output error. Then the ratio to the ratio of error for updating the weighting the W11 must be higher than the ratio of error for W21. Okay, I'm only review at this moment. We explain how we backpropagate the output errors to the previous layers and neurons. Okay, and then finally we said that okay, we could present this strategy in this form of matrix. Then after that, any questions? Okay. Because I pass the pages fast and explain fast. Okay. And then finally we said that okay, the output of neuron core, for example, for 3 neurons and 3 layers could be calculated by this equation. But sometimes our neurons, the number of neurons is higher than 3. Maybe we have 20 neurons or 100 neurons, more than 3 layers, and this calculation is not easy. And till these pages, we said that okay, we can divide the output errors to the previous layers. We back-propagated the errors to the previous layers and neurons. But we didn't say how to update the weightings. The question now for this session, we want to understand how to update the weightings. Maybe somebody said that okay, by try and test, we change the weightings and then find the optimum weightings for our data. But it is too time consuming and it takes too energy. It is not a good way and good candidate to find the best weighting in this way by try and test. Maybe sometimes okay, our neural networks is small, the number of neurons, the number of layers is not too high, but in general we must find the mathematical methods to find how to update the weightings and how we can understand the updating weightings is good. Our constraint again here is that okay, if we have 2 small errors, in the output, then our weighting is good. But if the error is not small, is high, then we must repeat the updating weightings to achieve the desired small error. Okay? Then our goal in this session is clear. We want to have the small errors in the output layers, and how we can access this desired error by updating the weightings of connections. Okay. Now we want to study the book and explain how we can achieve this goal. This photo is security and said that imagine you are in the mountain, for example, and hills, I don't know, in the night, and there aren't any persons in this environment. Only you have one torch here, and then you want to walk slowly, and step by step you for example move from this point to this point. By this torch you only can see in front of you. You cannot see here or here or here, because the movement is limited. You only can see in front of yourself. Okay, then you walk only one step. Then you see in front of you. See that, okay, it is safe. Then I walk another step. And then step by step, you achieve this bottom area. Okay? But what is the relationship between this story and ratings, updating ratings? At first, we want to introduce gradient descent. And then after that, we connect this gradient descent to the arrows and updating ratings. The gradient descent acts like this photo, like this person. The gradient descent contains a gradient. Gradient means deviations, differentiate. Then if you have a function, you calculate the deviation, you calculate the differentiate, and then using the slope of the function, you can understand how to move along the function. And our goal in the gradient descent, that in this neural network, is that you want to achieve the minimum of the functions. The minimum of the function. For example, consider this. Our function is y is equal to x minus 1 power to 2 plus 1. It's like this. And then you are here. You are this red circle. Okay? And then you, using the gradient descent, you calculate the slope on this function in this point. Okay, it is negative, then it is good, and then you walk. Then again you calculate the slope, and then step by step you will achieve to this minimum area. And then in this minimum area you calculate again the slope, and then set that okay, it seems that we want to pass this minimum, then it is not good. Then we stop on this minimum area, on this minimum point. Okay? Then the concept of the gradient descent is like this. And the question, maybe one question is, why we want to achieve this minimum? Why we want to achieve the maximum? Because we want to have the minimum errors. Then the minimum, if we consider the error, is the function of weightings. Okay, then according to the weightings, we want to achieve the minimum errors, not the maximum errors. Okay, because of this, our goal is to achieve the minimum of the function. And our function here in the neural network is error. And error is dependent on the weightings of the layers. Okay? Any questions? No questions. Okay. And here, it wants to say that if we are here, if you are here, then you moved from this point and then achieve the minimum. You don't move along to the upper. And if you are in this the second state, you are here, then to achieve the minimum, you have to move, you have to walk along this direction, not this direction. Okay? Then the negative slope, positive slope is too important for us for our moving. And this diagram is this diagram wants to set us that, okay, here attention to the steps. The steps here, the length of this step here is this, and this. Step by step, the length is smaller. Okay. For example, if you have here, for example, you are here. Okay, I numbered it 1, 2, 3, and 4. Imagine that you are in the third state, and in the third state, if your length of a step is this, then you pass the minimum. You are here. And then continue. Then you confused. What is the minimum? Then the length of steps is so important. Okay, and how we can understand the length of a step according to the function, according to the feedback of the gradient descent methods. Okay. And now another important, Imagine that you have 3 layers or 4 layers, okay, and then you calculate the outputs, and then after that you calculate the error outputs. This error output is dependent on this weighting, this weighting, this weighting. Okay. Then, according to the number of layers and neurons, always don't have only 2-dimensional arrows. Maybe you have 3-dimensional arrows. You have a surface, and then you are here. You want to achieve the minimum. Then this minimum is the best, or this minimum is the best, or this minimum behind of this. Which of them is the smallest minimum? The smallest error is the best. Then you move along this direction, achieve this arrow, and then achieve this arrow, compare these to minimum, and for example say that okay, this minimum is better because it causes the minimum errors. Okay. And another thing that is important is that the initial points, the first points that you select is also important in gradient descent. Because, for example, here is you are here, then step by step is minimum. This minimum value are right diagram according to the length of steps. You pass this local minimum, and then finally you can achieve the smallest minimum of this function. But in the middle, the initial of the middle and the right is similar to each other, but the length of a step is completely different. Attention. The length of steps here is this, but here is this. Then in the right, it passed this local minimum, but here it falls in this local minimum, and then we cannot pass this local minimum. Then it is not good. It is wrong. Okay. Now, you, of course, I hope you understand the concept of the gradient descent. Okay. And at this moment, we want to this, for example, and our desired output, target output is this. Then you can get this equation: target minus the calculated output. Then it is 0.1. In this way, target minus calculated output is minus 0.1, and here is 0. And then if you calculate the summation of all the errors, it is 0. You have errors, but it shows that you don't have errors. And another thing, and calculate the absolute. This, and here 0.1, 0.1, and here it is 0. The summation of them is 0.2. Okay. And another way to calculate the error is the second power of this target minus calculated outputs. Okay. If you use this equation, it is 0.01, and this is 0, and the summation of this is 0.02. The calculate by these two methods. See that it is so smaller here. It is 0.2, but here 0.02. It is less. Then it is better. And because of this, usually in the classification, neural networks, or in other classification, for example in SPM or other classification, they use these methods, this strategy. Okay. And then after that, as we said before, we said that in neural networks our function is error, and this error is dependent on the network link weights, for example Wij, and then we want to find the minimum of this error, and we use the error gradient descent, we use the slope to achieve the minimum error. Okay. And again said that, okay, if we have different layers, more than 2 layers, then we have surface. And then you know the error, and now we explain that we calculate the errors from these equations. And in this diagram, you also see that this error is dependent on the all the views session. For example, this weighting and this weighting, and this error here, the error here is affected by this weight. Then if we calculated this differentiate according to W, according to the weightings, we can achieve the results. Just a minute, we will achieve. Okay. And A. Okay. In this also set simple neural network, we have this. It's not important. And then after that, it said that okay, only we consider the weightings that affects on each error, output error, and then using the chain rule. You have this chain rule in the mathematical courses. The book divided this differentiate by using the chain rule and said that around the OK multiply, because they can we can delete it, achieve this. We called it is the chain rule. Okay, and then why we use the chain rule? Because we can calculate the error at each node. Okay, the error at each node is target curve, for example, minus the calculated output to power 2. Okay, we have this. We don't have the relationship, the directly relationship between the errors and the weightings, but we have this, and we can calculate this. If you calculate this differentiate according to O, you know this minus here, then we have minus and 2 multiplied by this, and then this multiplied by run the OK to run the WJ. Now in the next step we will write the mathematical equation of this OK. Okay, if you remember, okay, Zahra said that how can I get target? We know that according to our data, we know that. For example, consider that you have two kinds of data, normal people and Alzheimer people. You have an Alzheimer subjects. Okay, then you know if you remember in the previous sessions, we said that we labeled data. Do you remember, Zahra? We labeled data, and then we have supervised learning. Neural network is supervised learning. Okay, then we know the correct target, the correct outputs. Okay, if we calculate the outputs, and then after that compare to the correct outputs. These correct outputs, we called it targets. Okay. Calculate the outputs. This is related to the previous discussion. Then in this equation, it said that because we want to calculate, okay, this output curve or curve is calculated by this. Okay, it is related to the previous weightings and then pass through the activation function. Okay, and now we want to calculate this. It said that you know the sigmoid function. Sigmoid function is like this. Okay, and then said that okay, in the appendix you can follow the deviation and differentiate of the sigmoid function, but the result is here. The result of this differentiate of sigmoid to x is here. It is too simple, but the result is here. Now consider this and this. This is equal to this. Okay. This is sigmoid x. This is sigmoid sigma w j k multiplied by oj. Okay. And then according to this, only we replace the x in this because the direction, the slope is important. Okay, because the slope is negative. For example, 0, positive, or no positive, it is the minimum. Then we stop here. The direction of the slope is important, not the amount of. Then we can delete this. Okay, now we can calculate the slope of E, but till now we cannot update the weightings. Okay, we said that okay, this is error function, for example, and I use the slope, or we want to achieve this. How we can update the weightings. In the next session, we will explain and we will study about the updating of weightings. And I think I will record and see and watch the video. Okay? Any questions? No questions? Okay. Thanks for your attention, and thanks for your time, and thanks for participating in this class. Okay. Good luck and good afternoon to all of you. Bye.